We are solving question 10 of GATE 2014 Chemical Engineering paper related to process control and instrumentation. The question is, a unit impulse response of a first order system with time constant tau and steady state gain Kp is given by which of the following option? So in this given question we are given first order system with time constant tau and process gain at steady state as Kp. So the model equation corresponding to first order system, you can write it as tau dy by dt plus y is equal to Kp into x, where x is a function of time, and corresponding to this, the transfer function by taking the Laplace of this equation, we can write it as g of s is equal to y of s upon x of s is equal to Kp tau s plus 1, where x is the input that has been provided to the system and ys are the output or the values measured by the system. Now in this question we have been given a unit impulse input. So this is our xs. So by unit impulse input we mean to say that if this is x versus time, so by unit impulse input, we mean to say that the input to the system is of this form, where this is a time, let's say 0, b, and the magnitude is, the area will be a, so this will be a upon b. So this is our impulse input. Similarly, if the step input, we can plot it as this is a t, and at time t equal to 0, we are just giving a step input, that is basically increasing the magnitude by a value of a and keeping that at constant. So this is step input. So other kind of input that we can provide to a system is a ramp input, in which we keep on constantly increasing the input value x t, and the slope we can write it as b. So corresponding to this, let's say last one is ramp input. So corresponding to this impulse input, we can write the transfer function of impulse input at x of s is equal to a upon s. Now in our question, we have been given it is an unit impulse input. So the transfer function so the input in terms of time s domain will be 1 upon s. No. So in case of this impulse input, x of s is straight away a, and in case of this step input, we write it as x of s will be a upon s. So in this case, the input transfer function, that is x of s, will be 1. So we can write the transfer function of the system as xs is equal to ys upon xs to kp upon tau s plus 1. Xs we have been given 1, so this will be equal to y of s, and tau and kp we will keep it the same. So that is, we can now write y of s is equal to kp upon tau is equal to s plus 1 upon tau, or in other words, you can also write it as kp upon tau is equal to s minus of 1 upon tau. Now to find this in time domain, so in this given question we have to find the what the response of the first order system in time domain, that is basically in time. So we need to take the inverse Laplace of this term. So L inverse of y of s is equal to kp into upon tau into s minus of 1 upon tau. So we know that if the, let's say, function in terms of s is given as 1 upon s minus a, then L inverse f of s is written as e raised to at. That is basically f of t is equal to e raised to at. So that is why we change this equation in form of this 1 upon s minus a, so that we can straight away use and replace these values. So here we can write it as y of t is equal to, this is anyway constant, kp upon tau, and this we can compare this as 1 upon s minus of 1 upon tau with 1 upon s minus a. So from that we can get a is equal to minus 1 upon tau. So using this Laplace inverse formula, we can write this f of t is equal to kp upon tau into e raised to at, where a is minus 1 upon tau. It will become e raised to minus t upon tau. So the output response for an unit impulse in time domain is given by this term kp upon tau into e raised to minus t upon tau. So that is, from the given option we can select option B as the correct one.